All right, today I will be going over this Spring Security OAuth remote code execution as explained from this blog post. And this was discovered in 2016. So I think the first step I want to do is I want to sort of quickly jump over to my environment here. And so this is going to be the OAuth URL that's going to trigger this vulnerability to get remote code execution. So basically, for one of the values here in the URL, say it's 123, right? I hit it, and basically it tells me back, oh hey, right? The 123 value, it's invalid, and so basically it's sort of using that value I put here in the URL and giving me that error message. So I believe the vulnerability is if we do this kind of an expression, this $ parentheses, if we do that, then potentially we could get code execution. So let's go 6666 right here, right? So we do that, it says that, but check this out, right? So we have that numerical value, let's do -1. So we do that value and -1. So basically we have some type of execution, some type of evaluation, right? Code evaluation, where the subtraction was evaluated and executed. So in contrast, if we were just to take rid of the $, perhaps, let's do that, right? If we got rid of that $, it would just show it the string. So there's no evaluation happening, right? So that shows we now have some kind of code execution. So before I sort of go more in terms of how we can eventually use that to do something more interesting for a payload, let's kind of go through the details of why the vulnerability happens and identify potential fixes for the patches, right? So if you go to this blog post, it gives you kind of like a little bit more detail about what I went through. And then finally, it goes into the code, right? And so it says in the code, there's this class called white label here. So there's white label, and then it does some kind of error handling with right here, right? The OAuth error, it does some kind of error handling there. And basically, in the error message, let's see, going down here. So basically, you have to go to this one place here in the code called SpEL. So SpEL, what's that, right? So the code here that we're looking at, it's a part of the Spring framework. And basically, this SpEL is this Spring evaluation language here. Nice. Yeah, so someone sent the link there. So so it's an expression language that Spring has, basically. So basically, what's happening is that when there's an error, it does some kind of processing with all the different data. And in this case, what we have here is we have this render. So the render will do some kind of code execution. And what is it going to code execute, right? So what it's going to code execute is this variable called helper. So if you look earlier in the code here, what is helper? Helper is this new property. So basically everything within this kind of construct, within a $, open curly braces, close curly braces, right? That is what is going to be set to helper. And basically everything within that syntax, $, open curly braces, close curly braces, it's going to render that. So that is the place in the vulnerable code that allows this kind of execution with that Spring EL, that Spring evaluation language. I might be wrong in terms of the name for the acronym, but that is sort of the functionality that gives us that code execution, right? So as explained here in this part of the code block, right? So, and then again, right? So it's explaining what I did, where everything within this $ curly braces, right? It will evaluate, and then it will then spit out the results of the evaluation. So the other thing I want to do really quickly is, how do they go about patching it? Let me try to make this a little bit bigger. So this is the actual patch right here, right? So the stuff in red is the original code. The stuff in green is new code that's been added to fix the vulnerability. So basically, they remove the previous code where the helper was set to this dollar sign, the template for it was set to this $, open curly braces, close curly braces. And now the patch will generate a random value instead of that $. So basically they're using randomness instead of something that can be easily search for, right? Just search for directly. So that's what they're doing here with the fix, is they're creating a randomness instead of just this $, curly brace. So so that kind of explains the vulnerability, and that kind of explains a patch. One of the things that I did want to do though was, all we did here with the expression was just we added some numerical value and we did a subtraction. And I want to do something a little bit more interesting, right? So this other blog post here from this other place, it kind of shows you what else you can do. So the first part here, right? It shows that same thing where it shows 7 times 7 and then the output is 49. So what we want to do is make it a little bit more interesting is let's sort of actually get some, so this other payload, it uses this toString and this replace to show how you can use what looks like Java string functions to get Java string code function to actually execute. So we could do something equivalent to show that off, right? So let's go ahead and try that out. So in this case, let's see, toString replace. Nice, thank you for the links. So let's see if I can actually cut and paste just to make it a little quicker to finish this up here. So I'll copy this stuff up here, and all right, we'll put it all here in our curly brace, paste it, and to make it a little bit more interesting, let's do the original first. Let's do the original first. So the original is that it's just going to do this ZKZ string, right? So let's hit it. Ooh, interesting. So in this case, it just outputs it. So it didn't actually execute it, but let's go through like the whole payload, right? So the original string is supposed to be ZKC, and then it's going to replace the K in the middle with an X, but I want it to be a big X instead of a small X. So let's do that. Oh, freaking. Oh, thank you. Yeah. That was a test and one of my participants found the bug. So basically I forgot to put that $. So that's why we didn't get code execution. So let's go first for the original, right? So the original, again, that toString will do that ZKZ, and then we do the whole thing to replace the K with the X, right? And then it executed properly. So basically what it showed is that for the payload, you can get actual Java code to run. And as an exercise for the reader, they can do some research to figure out how to go about getting a shell with this vulnerability. And that is what I had for my demo today.